Welcome. This is a full-blown lecture about VMware vSphere, and the training is called Basics, but you could imagine it's going to encompass some features that could be found only in certified professional course from VMware. And of course, everything is going to be condensed, but in enough quality to get the overlook and to understand the concept. And I'll keep making further videos about specifics that should help to dig deeper into the material. The training itself is large, so feel free to take a pause, stand up, go outside and enjoy yourself otherwise. If you have any question about specific section, I'll be happy to answer any of those. Post them in the comments. So let's go. In this training, I'll be talking about hypervisor called ESXi. So this is the VMware provided hypervisor. So let's quickly look into what hypervisor is. So our goal is to run virtual machines. If you want to know why, take a look at the video, which is called Basics of Virtualization. It's pretty short and it explains all the benefits you can get from the virtualization. The virtual machines must have a virtual hardware. So the emulator of operating system must have access to CPU, RAM, hard disk, etc. So the hypervisor is something that provides this functionality. It's something that provides virtual hardware. So the hypervisor could be an operating system or it could be a hardware in rare situation. It could be a hardware solution. But in our case, we're talking about the ESXi, which is a hypervisor operating system. And when we are talking about hypervisors, there will be two common terms. So there will be the main computer, which actually has a lot of hardware. It has, let's say, 512 gigabytes of RAM. It has 64 CPU cores, right? And that would be the server running the hypervisor. So we will call this server the host. And the virtual machines which run as processes on this host would be called guests. So one machine is a guest. So in the future, when I'll be saying on the host, it will be something on the host level, so in the operating system of ESXi. And if I'll say something in the guest, it means that it happens inside of emulation in Windows or Linux operating system or any other OS that is inside of the machine. So in our case, ESXi is the host level operating system provided by VMware that allows virtualization. All right. So generally, there are two types of hypervisors. Type 1, which ESXi belongs to, which is called native. So if we say type 1 hypervisor or native or bare metal, it means that whenever you have the hardware, so here we have real hardware, this hypervisor is installed on top of the hardware directly. So you'll have OS or you'll have a hardware solution, which is type 1. And if it would be a type 2 hypervisor, you would have hardware, you would have OS like Linux, and then inside you would have like Oracle hypervisor or something else that is running as a part of OS. So a good example of type 2 hypervisor would be VirtualBox, for example. All right. So the Hyper-V and the VMware ESXi hypervisors that we discuss on this channel both belong to type 1. The Hyper-V may not look like it is a type 1, because what do? You usually have hardware, right? Then you install Windows Server, and then in the Windows Server you install Hyper-V, but it does something clever. So after you install the Hyper-V, it goes under operating system layer and it starts running the Windows server on the host as a virtual machine. So even the Windows OS on the host is technically a guest because it's virtualized on top of Hyper-V. It's a different partition from guests, but it is still running on top of Hyper-V. But today we're talking about VMware. So what is ESXi? ESXi historically was based on Linux. So in the past, there was ESX operating system, which was decommissioned, I think, around 2010. That's when VMware switched to ESXi. So ESX was running on Linux core. And ESXi has its own operating system, own kernel called VM kernel, which is Linux-like, but it's not really Linux. The idea was to focus entirely on virtualization and remove everything else that is not needed. For example, on ESX we used to have Perl installed. Now it's gone. But for some reason, on ESXi you can find Python. So for scripts you could use Python running on ESXi. Right now, the latest version I know of is version 7. But you can still encounter quite a lot of environments and data centers which run even versions 5 and 5.5. And I have seen as old as version 4.1, but it's pretty old now and it's out of support for sure. So how would you install ESXi? ESXi installation itself is pretty straightforward. What you would do, you would get a piece of hardware, just a computer powerful enough to run the hypervisor, and you would connect to it and either use CD-ROM or USB to mount an installation image. It's ISO file which you can download from VMware website. The only things you need to provide is the password for root, the partition to install on. So if you have multiple hard disks connected, you would select that one of the hard disks is the partition for installation. You would want to provide the TCP/IP settings. Let's say you would say that this is a computer with the IP address 172.168.0.25. So you would be able to communicate through networks. You would set up the time zone and keyboard settings. And these are the only things you need to provide to install. So it's pretty fast wizard. After you go through all of this, you will be presented with DCUI interface. And you will use this root password to log in into DCUI, direct control user interface, which can be used to tweak further settings. So let me show you. So this is the host and this is the web interface. You would be able to use it already, but before we get there, let me show what is the presentation from the DCUI layer. You would want to either physically open the screen of this computer if you use a physical server, or if it's a virtual machine, like in my case, which is running as nested VM. You would want to open the console of that virtual machine. So this would be the interface. You press F2, you provide your root password, and you press F2 again, and now you have access to the settings. You can change the password. You can configure the management network, which would be your network for connection. In this case, you can set up IPv4. You could use it dynamically through the HTTP. You could disable it completely, but then you wouldn't be able to use the web interface. You can configure DNS and suffixes if necessary. And if you go back, you can also set up keyboard and view the logs. So this is the most obvious interface you would get as administrator, unless you start working with vSphere client. Then this is something that I'm going to talk to you about shortly. So there is one more option which I didn't mention right now. It's restart management network. This is something that you would do if you want to restart the specific agent which allows you to manage the server remotely, including through Vcenter. So we'll get that shortly. Okay, so what are the internals of the ESXi? The ESXi itself, it has a lot of different processes like any operating system, but there are a few of the most important ones. So one of them is called hostd. And hostd is the management service, or daemon, because it's like a Linux, which is responsible for performing all the actions required from ESXi. For example, if you want to make a machine, the hostd will perform the steps. If the hostd stops responding, then you can no longer manage the host through vSphere client, and Vcenter will indicate the host is not available, but the running process of VMs are not really affected. So you will be unable to manage anything if the service goes down. And for this service in var log, you will have the hostd log. There's also VM kernel. And VM kernel is the kernel itself, it's not the process. And it's responsible for all low-level system operations. For example, working with hardware and drivers. So if something happens with the hardware, the host will likely to crash, and it has a purple screen of death. So it's not a blue screen of death, but it's purple screen of death. It also has its error codes, so it can be troubleshot as any crash. Besides these two processes, there is also VPXA, which is important if you use Vcenter, and these will be management agents for remote management of multiple hosts. And each machine will be a separate VMX process. So VMX is a process of a virtual machine. All of them run independently and don't share memory, so they will allocate different address space in RAM. So if one VMX would crash, it would not necessarily affect any other VMX processes. There are other processes, like for example, there's this UI, and this is the interface that we just looked at. There's Authd, which is used for authentication, but if you have worked with Linux, you will be familiar with other processes running, and they are less important for us right now. So if hostd crashes or hangs, you could check it in the var log, hostd log. The machines would still crash. So instead of rebooting the whole host, and in that case you would basically suffer downtime of the hosting machines, you could simply try to restart the management agents, which will restart multiple daemons, including hostd. So potentially it could fix the issue. So you would go to the GCUI, you would select Restart Management Network and press F11. But this could interrupt running expiration. So it should be done only when there is a reason to restart management agents, not randomly. Also, you could theoretically affect MPIO and other configuration at the time of the restart, so it should be a careful step. Now, as I have shown briefly, there is a web interface which you can use to connect to the host. Let me actually get there shortly. Hold on, where is it? Here. Yeah. So this is the main way users and administrators would control and create and operate machines on the ESXi. So here, for example, I have two virtual machines with different amount of space, different operating systems. So for this interface to work, it is called the vSphere client. It has to operate through HTTPS, so you would need to use a browser to connect to the ESXi server, which means that the ESXi server must have a management IP address configured properly and working, and you must have access to that interface through HTTPS through a specific port. In the past, there used to be a C# or C++, I don't recall, legacy client, which you would install and run on a desktop as an application. Now it's deprecated. Besides the vSphere web client, there's also HTML client, which comes with the newer builds. It runs in a browser and it doesn't use a Flash, because this one I'm pretty sure it uses Flash. The virtual machines run on the hosts, and you would connect to the host first, and then you would control specific virtual machine. Of course, the host itself must be functional, and it must have enough resources to run the specific machines. You could connect to the host through this vSphere interface, check if it's operational, make sure that you have enough RAM, CPU, and then you could go into extra settings, but you have a very nice overview of the CPU activity on this host, on the memory usage, on the storage usage. So from the first screen of the host itself, you can start analyzing the health already, and then you can undertake some actions if you are running out of space or if you would like to use more resources. So the virtual machines are processes that run on this host. But how do you actually use data in the machines? Well, the machines must use some kind of storage. For example, if you have a server with 3 terabyte disk or 3 terabyte file, the disk should be stored somewhere. So this is why you have a storage tab here, where I can see an SSD drive, which is right now provisioned for 30 gigabytes maximum. It's a test server. So let's say you have a server, a virtual machine with database, which has 3 terabytes of space on the sides, right? So you want to have a disk for this virtual machine to actually take at least as much space. So the machines on the storage level is just a bunch of files, and disks are also stored as files. So on the host itself, on the host system, you would need at least as much space to store the disk of a virtual machine. How would you attach the storage to this ESXi host? Let's look at different options. So the most obvious way is to have a directly attached storage, right? So you have the box with the motherboard, with CPUs, with RAM sticks, right? So you have this motherboard, it's inside of a big box, and here through a SAS cable, through SATA, you would connect a disk, right? So this disk would be a storage. It could be SSD, it could be HDD, and this could not only be a single disk, you might have a RAID. So for example, you could have a mirror, so 2 disks connected, and here you would have RAID 0, which means that they duplicate data, so it's the same configuration, but in both cases it will be a locally attached storage. The disadvantage of this is that no other ESXi host could have access to this disk. So if you have another host somewhere with another resources which would want to run the machine, so here we have, let's say, VM1, which is a process which actually runs in the RAM and has files on the storage. If you would want to start up this machine on another ESXi, on ESXi 2, then you wouldn't have simply access to that storage, and you would be unable to run the machine from another server. So you cannot have VM1 there. Okay, so furthermore, you could of course move the data by detaching and attaching the disk to another computer, but it's very inconvenient, and also you would somehow need to do it manually or create some kind of difficult process, so it cannot be automated. So the solution to this issue is a shared storage. So let's look at the possibility of shared storage connection. So if you have 2 ESXi servers, which means 2 real hosts with motherboard, with components, you will want to have a storage system which is somehow shared between both. So you would have access from both servers. How is it possible? There are different protocols which can be used, and in this case you could use Iscsi, you could use fiber channel FC, you could use fiber channel over Ethernet, or you could use NFS 3 or NFS4. So these are the protocols which can be used. Like in comparison, if you would have a local disk, it could be SATA, it could be SAS, SCSI. Right? So these are standards that you typically name for local flash storage. So let's take a look at these different common protocols. Before I can explain what is Iscsi, I have to explain what is SCSI. So before we do that, let's take a look at the SCSI common protocol. So let's say SCSI is SCSI common protocol. So what does it mean? SCSI is understood as Small Computer System Interface Common Protocol. It's an abbreviation, and it's some standard which is not tied to any specific hardware, and it's supported by almost, I think, every operating system, and it's used essentially everywhere to access any kind of block storage, such as disks, flash drives, and tape libraries. So if you have any operating system running, you would use SCSI command protocol, which is a bunch of instructions to read and write to disks, to flash storage, and to tapes. So what does SCSI actually perform? Well, basically SCSI allows you to do two main operations: to seek a specific offset on the storage and write data, or to seek specific offset on the storage and read data. And you say, here we'll write some data and here we'll read some data. So how is this useful? So let's say we are talking about using SCSI to write in Windows on a local NTFS hard disk. So you have Windows, which is your OS. In Windows, you have a program called notepad.exe. So you decide to save a file which is 1 megabyte in size. It is txt file. So the program will tell NTFS file system to save some blocks or clusters of data. Typically, each of them is 4 kilobytes, unless you change it, which would in total create this 1 megabyte file. This file system driver of NTFS file system would go to the partition manager, which would transfer all these writes into raw data writes, so 1001, etc. So you would have a binary data for 1 megabyte. Then the partition manager would use the SCSI interface, SCSI command, to tell the device to write on specific offset, let's say at 37 megabytes, because this is where your free space starts. And it would say to write 1 megabyte. And in the end, the command would be like 37 multiplied by 2024 multiplied by 2024 to get into bytes. And then it would say to write 1024 multiplied by 2024. So it would be two numbers. Where to get on the disk? So if this is your disk, it would say go here, and then it would say write this amount of data here. So that's the only thing that the SCSI would do. It would simply send two numbers. So from the very top of the complexity, when we were working with the software through file system driver, through partition manager, we would only write binary data using two offsets, here and here, from here to here. So SCSI is a very simple, let's say, method, and it is hardware agnostic. So any hardware device would be able to do that because it's a very simple set of operations. And now, if we are talking about, let's say, a more complex setup, when there is a RAID, so let's say you have a RAID of 2 disks and it is RAID 0, right? And you would like to write a file. So once you write this 1.txt file, it would technically be saved on 2 places. In terms of SCSI, it would still come here and say write 1 megabyte at offset 37 megabytes, and the actual RAID would be handled by the RAID controller. And if the controller is not actually handling RAID, so it's on the software level, it would happen before the command would be created. So then it would say write 2 megabytes in 2 places on 2 devices. But in terms of SCSI, it's still only 2 simple commands. And the same with reading. Even if the file is deduplicated, compressed, encrypted, when you go through SCSI, it will just pull some bytes at specific offset. All right. So this is what happens when you have a local storage and you use SCSI. It simply sends these commands in a very transparent for the storage device manner. So it would know where to spin the disk or where to go in memory and pull the data out. Now, what is Iscsi? Iscsi is the same SCSI but encapsulated. What does it mean? So it is a network connected storage that would use Iscsi. So you would have an Ethernet cable. And here you would have some kind of a box which supports Iscsi. So you would have your ESXi connected to the IPv4 address of this device using Iscsi client. Another name is Iscsi Initiator. So if I open my Windows, it is a software which exists in almost any operating system. So even in Windows, you have Iscsi Initiator, which you can open. And then if you start it up, you will be able to select target IP address to connect to. It looks like this in Windows. So you specify target, and then after you connect, you would see discovered targets which would connect it to the device. So the ESXi acts as Iscsi client, which means that the storage acts as Iscsi server. So the Iscsi functionality, the initiator and the server would exchange standard TCP traffic. And then the target device would open this traffic and use standard SCSI commands on itself. So basically Iscsi, which means internet SCSI. It is just SCSI which is packed inside of TCP traffic. And it allows you to handle remote storages as local disks. So if I would connect to Iscsi target in Windows, I would have local disks in Device Manager. So the disks themselves are not really disks. They are actually LANs or volumes. Because when you connect through SCSI, you need to select what kind of storage unit do you work with, block level device. So on the target computer, you would have partitions presented through Iscsi, and on the source client computer, you would get access to these partitions as local disks. Each partition has a specific identifier. This identifier is called IQN. IQN, I think it's like Internet Qualified Number. It is basically an ID of different volumes. So you will use this to identify which volumes do you see on your Windows computer. It looks like IQN.199.801.com, for example. So it looks like kind of an VMware IP address, because then it will be like .vmware if you use it on VMware system, and then you would have a server name. So it's like this long address, which looks kind of like internet address, but not exactly, because it has domain in it, but it uses double dot, which you don't normally use inside of internet address. So whenever you use this kind of connection, you must realize that the TCP traffic goes through real network interface card. So I wouldn't recommend to have at least 1 gigabit per second network card. Otherwise, the disk activity would be too low. So if you would have 100 megabit per second, you would only have basically 12 megabytes per second, which is very low for any disk activity. You wouldn't be able to run even one VM properly. So you would have a proper network card for Iscsi communication. More than that, if you intend to use ESXi in a cluster or to connect to it remotely, you would want to have a separate network interface card which you used for external connectivity. So your traffic uploading or downloading data would not affect your storage capabilities. Because if the traffic is actually used too much, if the storage becomes inaccessible, the machines could go in the pause state. But nobody wants to pause the virtual machines when they're working, especially if it's a critical server. Also, the Iscsi, if there is a connection problem, could technically disconnect completely, so you would lose disks of virtual machines. Not fun. And of course, you could even have a so-called Iscsi fabric. You could have multiple Iscsi devices connected to your hosts through a specific switch. So you would use some kind of important switch for storage only, which would allow multiple ESXi hosts to connect, because the final idea is that not only one ESXi can connect, but you could also have cable going to a second ESXi, which would also benefit from this storage. So Iscsi connection can be shared, even though it would look local on each ESXi. It would be the same device available to multiple ESXi servers. One more thing that could technically optimize this is that the specific adapter used for Iscsi could be HBA, host bus adapter. So HBA, host bus adapter, it's a specific type of network card which would be optimized and allow bigger throughput for your specific purposes. Also, if you are not satisfied with Iscsi and if you want faster connection, there is another protocol which can be used, which is called fiber channel. In case of fiber channel, you would use optics. So in that case, you would be left with no choice but to use specific optical HBA adapter. So you couldn't connect to standard interface network card. And then you would have optics going to your storage, which would also have a card which allows you to connect through optical cable. And this would be called fiber channel. And this protocol is typically the fastest. So ESXi would be able to pull data from and write data to the device very fast. So if you would use a fast fiber channel or Iscsi connection, the device would be called SAN. Do not confuse it with NAS, which is typically a storage device which is not capable of necessary speeds and doesn't have support of necessary protocols to set up this kind of connection. And the third and foremost method of connectivity which you can do to connect the storage to ESXi, but not necessarily through the fastest means, is NFS. NFS is a specific protocol which is similar to SMB, which is not used to share volumes, it is used to share folders. So it's not a block level access, it is an access which you give to specific folders. This protocol also works over TCP IP, like Iscsi. And what you do, you have a ESXi and you would like to connect using an NFS, which means that you would use a typical network card with an Ethernet cable again, kind of like with Iscsi, and then you would have this cable going through probably some switches and routers to your storage system. And on this system, you would have a volume. It could be even NTFS volume, not necessarily other types of volumes that you would use with VMware, like VMFS. And on this volume, you would have a folder. And the folder would be exported through NFS, that's the term, export. And it would be visible as a share if you connect using NFS to this storage using IP address. And if you use NFS v3, it's pretty transparent. If you use v4, you can also authenticate for security purposes. And then on ESXi, you would have a network data store, NFS storage, which is commonly considered slower than Iscsi if you use the same network. But of course, everything depends on the speed and the reliability of this network between two devices. So just briefly, how would you do this kind of action? It's pretty simple. So if you would like to connect the data store, the storage, you would go to the storage section where you see all the data stores. And here you have a button to create new data store. So if you already had an Iscsi over channel connected storage, you would create a new data store on this storage, and it would be in the list of the devices you have. So you would have new devices connected to Iscsi. And if you want to make not Iscsi, but an NFS data store, you would click on Mount NFS data store, where you would provide the target server IP and share name. And if you switch to NFS4, you can also provide username and password for authentication. And the name is just a description for yourself, so it's not important right here. So these are two ways to connect the storage, which would be specifically shared between multiple hosts. So why would you want to share the storage between multiple hosts? Well, most likely for clustering purposes. Because if you were to follow what we discussed so far, if you would install ESXi, you could do it multiple times and you could have multiple ESXi servers. Each of them would run their own VMs. Here we would have VM1, here we'd have VM2, etc. And if we actually had proper network equipment, we could use network cable to connect them to switch, and the switch could connect us to some device which has Iscsi capability. So here we would have Iscsi server, which means that whatever is the volume on this device, we could format it with file system called VMFs, which is used by VMware, and then it would appear as local disk on both the ESXi servers at the same time. So they could share the storage and do the same operations, but they're still not clustered because each of these operating systems are not aware of each other. So this is why we have a role which is called Vcenter. With Vcenter, you can join multiple hosts in the cluster, and from that point, the hosts could have improved availability, could have load balancing, and more. And you could also simplify the management, because in this case, if you wanted to control VM1, like log in into that or restart it, you would have to connect using HTTPS through vSphere interface to ESXi 1. And if you wanted to control machine 2, you would have to connect through HTTPS to the server number 2. So you would have two connections under different users and two tabs. If you were to install Vcenter, you would be able to connect to it and see both hosts. So if you connect through HTTPS to Vcenter, you would have access and control over two hosts. So the Vcenter itself, it could be a physical machine with a role, it could be a virtual machine. So initially when you deploy it, you create a data center. So let me get rid of some of this stuff. So in the beginning you have a Vcenter, so you deploy a data center. A data center is a logical entity. It's not a functional, but some kind of organizational unit. Usually it's some kind of geographical location or an office. For example, if we have an office in St. Louis and we have another office in Czech Republic and Prague or in Australia, For each office, we would make a separate data center. Now, in the data center, we would have multiple clusters. So under data center, we would have a cluster entity. And the cluster is a cluster of ESXi. And then after we create the cluster, we can add ESXi to the cluster. So through Vcenter, we'd have data center, then cluster, then host. Let me show you what it looks like in the UI. Hold on. Yeah. So on the top, we have Vcenter. Then we have a data center. Then we have a cluster of hosts. If you go to hosts, you can see which hosts are in there. And then you have separate ESXi hosts. So in this case, instead of connecting to each host through vSphere client, I can control them both from the same connection to the vCenter. Okay, so if the vCenter goes down or crashes, it's just a management server. So all the ESXi hosts and all the VMs would work properly. But the functions which are given by vCenter wouldn't work. So what are the functions? The first function is called vMotion. It's an action which allows you to move a machine from one ESXi to another. Why is it important? Well, theoretically, what you could do, you could go to the first ESXi, remove the machine from the configuration, then you could go to the second ESXi and add the machine to configuration. The problem with that is that every time you create or remove a machine, the machine gets an incremental reference. So it was machine number 1, then it will be machine number 2, then machine number 3, 4, etc. Every time you register a new machine, it gets a new reference. And most of scripts, backup applications, and other monitoring tools identify specific machine by this reference. So if you remove machine 1 and add it back, even though it's the same files and the same data, for the management and for the monitoring purposes, the machine is new machine. So you lose old scripts, you lose old statistics, whatever. So on the vCenter level, the machine would have its own reference, VM-number, like VM15. And it doesn't matter if you move the machine between ESXi hosts and it keeps changing the reference, it keeps the same reference on the vCenter level, which means that whenever this happens, like the machine moves, you can still use the old scripts and you use old backups to continue making up the same machine from the vCenter top level. You just need to specify the reference from vCenter, not from specific ESXi host. It's one of the features. Another feature is called high availability, HA. So if one of the hosts crashes, you can set up the machines from the host to be starting on the host number 2 or other hosts. And it's possible because the host has the access to the same storage and the same VM files. So this functionality actually can't work even if this vCenter is down, if all the hosts are configured, because they can exchange information that some hosts are missing or not available at the moment. And this is how you can secure your vCenter. So your vCenter is quite often a VM. So if the host of vCenter goes down, even though theoretically you would lose the clustering capability, the high availability feature would bring back the vCenter. And you could also do it manually in the worst case scenario. And the third feature provided by the vCenter is called DRS, Distributed Resource Scheduling, something like that. So DRS will move the machines from the hosts which suffer RAM and CPU problems to the hosts which have less RAM and CPU usage. So you can load balance. So vMotion, availability, and load balancing all allow you to distribute the machines accordingly to your needs and resources and not completely destroy one of your hosts. So let's look at these features. Each of them separately. So vMotion. What does vMotion actually do? vMotion is a process of migration of virtual machine from one ESXi to another. So while ESXi 1 runs VM program, so it's VMX process. If you move it to ESXi 2, this process gets paused, so it's no longer running. It's actually saved on the disk in the VM files, and then these files are used to start a new process on the ESXi tool, and the memory would be used to unpause the machine. So now it's in play mode. So for the user, there would be a brief interruption, but in reality, the whole process would restart on this different server. There's also SVMotion, which is storage vMotion. Let's say you have a folder on NFS data store, and this is where your machine files are located. So this is where you have your virtual machine files. You would want to move the machine maybe to a faster Iscsi data store. And the idea is the same. The machine would actually wait until the files are copied, get in a bit of a pause state for a brief moment, and then resume. So you can move the machine between the ESXi hosts, and you can move the machine between storage data stores, clusters, and units without actually shutting down the machine. It's a seamless process. Another process is called DRS. Let me see if I have access to this functionality. If I go to the cluster, monitor, and DRS, yeah. So this is where you can set up the utilization minimums and maximums based on your needs, and this would allow you to basically switch the machines between servers, CPU, and memory utilization programs. And this DRS can be quite useful if you don't want to babysit each virtual machine. For example, if you have thousands or hundreds, even maybe dozens of virtual machines, it's still hard to provision them properly, to give them all enough RAM to fully utilize the resources on one host, but not crash it. So with this feature on, you can enable and disable it per machine. You would be able to tell Vcenter to automate the task of moving the machine to the most appropriate host. There's another set of rules called affinity, and this is how you could force the machine to always run on the same host. All of this can be configured on the machine level. Here, let me see. There is fault tolerance, there are policies, yeah, storage policies. Right now, it's grayed out because I'm not an administrator, but you could apply the policies which would tell the machine how to behave if specific conditions are met. There's also storage DRS, which can be used to load balance your storage space. It is essentially the same, but for data stores, not for RAM and not for CPU. And the high availability feature vSphere HA, it is a specific setting which gets basically installed on each ESXi host when you deploy the cluster, which allows the hosts to react to other hosts crashing. So you could actually have separate host designated for high availability only, which normally doesn't work, but it would start taking and restarting the machines if some of your hosts crash. That would be like the best practices setup. Another technology which is part of high availability is called monitoring of the machines. Let's say if the guest operating system hangs, the host can still restart it because the host can learn that the machine hangs. For this to be possible, the machine must have VMware Tools installed. So you would go to guest OS and install VMware Tools, and the VMware Tools, as you can see on this host, it's running. It's a guest application which you can install from the host, which gives you information about the IP address and also tells the host what's happening with the VM. So it's like a spy in the guest which tells what's happening. And if VMware Tools stop responding, you can trigger the restart of the specific virtual machine. Another problem-solving solution is called fault tolerance. It's technology that prevents memory and data loss in case of host shutdown. So there are like legacy and current versions, but the general idea is the same. If you enable it for a specific machine, that machine will have a copy on another host. And then it would synchronize two machines together. So if you would go to right click, there is a fault tolerance which you can turn on, and then you could pause it or you could resume it. So if you suspend it, of course, it's not going to use the network that much. If it's on, whenever you do something in the machine, a copy of the machine would get updated. So it's like an exact replica. And if the host with the primary machine goes down, the cluster would switch execution to the secondary copy. There could be a short downtime, but there's almost no data loss because even the memory of the machine would be synchronized. And the same procedure can be set up for the whole data store. So you can have fault tolerance of all your data. It's like a policy, basically. So whenever the host goes down, fault tolerance immediately reacts. That's something that is not always set up because you must have enough physical resources to enable fault tolerance, but it does provide a pretty significant protection in case of immediate crashes of your server software. So it's not a long-term backup capability because the secondary copy is always up to date with your existing machine. So if you lose some files, if you get ransomware attack, it's not going to help you. But it helps against unexpected host shutdowns or unexpected crashes or loss of a host in the data center. So how do we deploy Vcenter? At first, you could download an ISO file from VMware website and install it in your Windows OS. That would deploy the necessary services, but of course it would give you an overhead of extra files and storage that comes from Microsoft. Another better option would be to use Vcsa or Vcenter server appliance, which is an image. So you download OVA file. It's a template from a website of VMware, and you deploy it as a virtual machine, which basically has everything unneeded cut out. And it only has what you actually need to run the Vcenter. The Vcenter itself needs to have a database separately because it has a lot of information, including performance data, monitoring tasks, events. It can store data up to 1 year. I think it's 1 year by default. So if you use Windows OS, typically you have ability to use Microsoft SQL or PostgreSQL. But there are some limitations unless you use a paid version of SQL, otherwise the database may be not large enough. And on Vcsa, you already have PostgreSQL installed. You could also theoretically connect to Oracle instance to run the database. So all these options are possible for database. So typically you would run Vcsa, which already has the database installed. And the reason why you would want this database to exist, it's a necessary feature of Vcenter, you must have it, and it would store all the settings, all the history of performance data and tasks, events, and host activity for a long period of time. So what do we have on the Vcenter? Well, if it's Windows, it's kind of boring. It's a Windows service with some extra components. Let's look at the Vcenter on Vcsa. So we have Vcsa. So it is a Linux. You could connect to it using SSH. So port 22. And you would use the user, which you have configured as administrative user. I'll have a short section about permissions briefly. So on this server, you would have VPXD daemon, which is actually VPX daemon or Vcenter daemon. That's the main service which actually runs the Vcenter. Once you add the hosts to clusters in Vcenter, ESXi hosts, they will have VPXa installed, VPX agent. And those will be communicating with VPXD for management purposes, using the management network and web kernel IP interface. And besides this, you will also have single sign-on SSO available and installed. It is responsible for all authentication on the Vcenter. So every time you would try to log in, the single sign-on would check whether the credentials are correct, and it allows you to add your Active Directory domain as an additional identity source. So by default, you would have vSphere.local as a domain, which is a part of a standard Vcenter installation. But you could also add your own domain from your organization, which would also use single sign-on for connection. And of course, you would also have the web client running using HTTPS, but it's simply a HTTP server which returns the web content, and then it provides you access to the data available in the Vcenter database and to the function and methods which would the PXD service use. Right. So let's clear that. Okay. So the features like vMotion, availability, and specific APIs used by backup software are not available in each edition of ESXi. So there is free ESXi, which somebody or anybody can install, but it will miss most of the features we mentioned above. And you couldn't install Vcenter in that case. And due to the lack of APIs, you will be unable to do most of the scripting and backups. So you would want to basically use any paid edition of ESXi if you would like to utilize the Vcenter and features. There are 4 different options. I'm not going to look at the pricing or specifics because you basically decide on the size of your environment and everything else is extra. But the main idea that if you use a free ESXi, you can use it for learning purposes. You can even deploy virtual machines for real infrastructure, but you will unlikely be able to back it up properly unless you use some convoluted strategies. I can talk about backup later if you want. So how does authentication work? So when you deploy the ESXi host, the standalone version itself, as I mentioned before, you would set up root account password. So you always have a Linux-like root account, which you can use to log in either using HTTPS, or you could connect to the host on port 22 using SSH. By default, it wouldn't be possible because this connection is blocked. So the SSH server on the host is not running. You need to start it. It's pretty simple to do. You would go to the host. Let me find it. Here it is. You would log in, and then you would be able to click on the Manage section, where you see different services, and one of them is called SSH, which is stopped, as you can see, but you can simply start it with one button press, and then you'll be able to log in if you would like to operate it as a Linux machine. Let me check. I'm pretty sure you could also do it from this UI. Let's see it together. Troubleshooting options, enable SSH, yeah. So you could also enable the SSH from this UI if you really needed to do that. So that's how you could connect to ESXi. You could also make Linux-like users with limited permissions, which would also be able to access the ESXi. And on the ESXi itself, in the vSphere interface, you would be able to go to security and users and create new users here. So that's also an option. You could do it from the shell, from SSH, or you could do it from here. And if you create a user here, let's say we name it test, and we give it a basic password, which is too short. Here we go. Now I can change the role. So if I edit this user, it is right now a specific user. And if you go to the roles, you can see that there are various roles I can assign, and I could create custom roles, which would allow me to specify access to folders, to host, to network, to performance. So I could create my own room which I would give to a specific user if I wanted to. Right. The vSphere client connects on the HTTPS port. This is a port for TCP for free, where basically all the API commands are sent. Also, you can use different applications which would interact with vSphere. And those applications use a separate protocol, which is called SOAP. It also goes through HTTPS. That's a protocol for API commands, like for scripts and for backup applications. Besides that, you can also try to download and upload files from the storage, and that would use a different protocol. So if you want to access data on the storage, and the data would go through ESXi, let's say you have a local Iscsi disk here, and you have VM files which you try to download from the interface of web client. The files would go through network stack of the host, and then they would be given to you. And this would go through network card of the host through specific port 902, which is called VM kernel IP. And this is network file copy protocol. So if you try to interact with files on the storage, upload, download through the web interface, it uses a specific port 902, it's a TCP port, and it uses a protocol NFC to retrieve the files. Also, this port 902 is used for communication between the ESXi hosts and the Vcenter. And this VM kernel IP setting is defined also within the vSphere client itself. So if you would go to networking, here you have a setting called VM kernel NICs, where you can assign a network to a specific physical network card, and you could give an IP address which would be either configured manually, and you can see it's the same address you see inside of this interface here. Let me go back. So if I would go to configure network, where is it? Management network. Yeah. So you can see that here I have IPv4, which ends with 182, and this is the same setting I hear and I see here, which ends with 182. So there are two ways to access the same configuration, which would allow you to manage the server. And specific port 902 would be used for data transfer. So NFC connection, where you download and upload files, is very important because it is also used for migration between hosts. So the vMotion and storage vMotion that would basically download the VM and move it to another ESXi somewhere else. So let's say they have another ESXi. It would also go through this port 902. So these ports between ESXi on the IP that you configure as VM kernel IP should be open on the network. Otherwise, you would be unable to do vMotion and you would be unable to download files. Once you configure standard networking, you could consider which network card is assigned to this VM kernel IP if you would like to determine, let's say, or define how much throughput you actually have. So if you would use a slow network card, you could expect slow vMotion, slow migration, slow storage vMotion. If you would use a faster network card, you could typically expect better speeds, and you would probably want to use this card separately from the card which is used for your Iscsi traffic, which would normally allow VMs to communicate with the storage. So Iscsi would be one channel for one network card, and a VM kernel would be another channel from another network card. This way they would not overflow and mess with each other. So most of the operations are done by root as authentication, including the file downloads, unless you make a custom user. So what about Vcenter? When you deploy a Vcenter, it doesn't matter if it's a Vcenter on Windows or on Vcsa and Linux appliance. This gets default vSphere.local domain, and it gets a default user called administrator at vSphere.local. So this is a built-in admin, and even though it's kind of a local, it is still in the domain of vSphere, so it still uses SSO, single sign-on service. So if this single sign-on is down or malfunctioning, it can also affect login with default administrator. The way you set up the users is similar to ESXi in vSphere. On the top level of Vcenter, you could go to the permissions tab, and here you could create groups and users. So you could create groups in the default domain, and you could also connect domain controller, which would allow you access to a different domain. And this is how you could basically put multiple users from different organizations to work with the virtual environment, because they would have access from different domains. And here I cannot edit them right now, but you would specify which Active Directory the group is coming from. Okay. So generally you would be okay with default vSphere domain, but if you use, let's say, accounting and IT and administration as different domains, it also makes sense to make 3 different domains with different rules and roles in your virtual environment. One more thing that is curious that you can set up for, let's say, permissions administration, it's called tags. So on the machine, you have a specific option called assign tag and remove tag. So while you could put machines under different hosts and in different logical folders, you can also tag them for easier management. For example, you could create a tag which would say critical machines, and then you could create a tag which would say IT service, and a tag which would say business administration, and then these tags could be used instead of containers, instead of hosts, in scripts, in backup solutions, and in monitoring. So you could easily assign and remove tags and then move the machine around without actually moving it. It's just useful for monitoring. So this tag functionality comes from Vcenter as well. So you wouldn't be able, like if you have a Vcenter, if you don't have a Vcenter, you have ESXi, on right click here, you don't have a tag option. So ESXi doesn't know what the tag is. Now we are coming to the situation where I wanted to show you how does Vcenter actually identify the machines. So I mentioned that machines have references 1235 or VM15 or VM25, but here you do not see it listed anywhere because this is a standard user interface. That reference is more of an administrative side of things, closer to DBA or even VMware support scope of functionality. So the only way to see your machine reference is to look at Managed Object Browser. What you would do, instead of providing the Vcenter IP only, you would also add /mob, and then you would be able to log in using your credential in the database of Vcenter. And it's not only the database. Fortunately, I think I used the wrong password. It's not only the database, it is also access to actual VPXD functionality. So you have methods like programming language methods, which could trigger activity. So these methods shouldn't be played with. It's safer to use web browser interface. But you can go to the content and find your data center. Usually it's something with square brackets with names, so it's easy to find in the list. Here you have the data center, here you have the VMs, private VMs, and now I can see my group of all the machines I have. And I can see not only the name, but also a managed object reference. And if the machines would have snapshots and other things, they would also have their own internal references, like here. It says managed object ID. And it means that if you are in a task position where you need to make scripts or use backup applications which target machines by reference, you can look in this managed object browser to find the necessary ID for your script or for your task or for your monitoring tool. However, as I said, be careful with the tasks, because you can theoretically even remove the machine or delete it using a specific option. Something that you can do from the web interface, but in the web interface it's much more user-friendly. You don't have to provide like a method with parameters like you would use a programming language. But your scripts and backup applications would actually use these methods. So for example, if you are troubleshooting a method and it fails in your application or in the script, you could theoretically go here, trigger the method, and see the real error that comes up in Managed Object Browser. You could also go and see the errors in the monitor section. Here you would have events for ESXi, and for Vcenter you would have tasks and events, where you could see more information about the errors before you go deeper into VMware logs. Now, I have to specify quite a few extra details about virtual machine files. So far, we have said that on the ESXi, which is an operating system, you would run processes, like a tree of processes. Each of processes is called VMX if it's a virtual machine. And this process would be a standalone emulation of specific hardware, virtual hardware. And then you would basically run like Windows or Linux of any kind, Solaris systems. So that would be already inside using the virtual hardware. But how do you actually store the configuration? How do you store data about the machines? Well, we briefly discussed that we have some kind of storage disk connected to ESXi hardware. It could be through Iscsi, it could be through SAS, it could be through NFS. And here you would have a folder with files. So the process reads and writes VM files. But which files? Let's take a look. So the VMX process has configuration, which tells how much RAM does it use. It should translate into the CPU and RAM and other settings. So the process, which is VMX, is actually running and consuming, let's say, 10% of CPU of the host and 2 cores. And it consumes 4 GB of RAM. All of this needs to come from somewhere, so the host would know how much total RAM and CPU cores and everything to give. So all of this configuration is stored in machine name like vm1.vmx file. So the VMX process is working or starting or registered from file called VMX as an extension. And this is the file you can find on the data stores. Let me show you. If we go to the storage and we browse the data store, here we'll have a folder with machine name, and here we have the VMX file. So this is the file, which is a text file actually, which would contain all the settings. You can download it, open it in Notepad, and here you would have actual text representation of the machine settings, the same that you would set up in the vSphere web interface. You will also see that there is a vmdk file. So because the machine needs to store data somewhere, and inside of emulation it has a hard disk, the supposedly real hard disk, which would have volumes. So let's say here you have your C volume. All of this data has to be stored somewhere. So on the same data store, in the same folder, you'll have a file called vm1.vmdk file. And it's a pretty small file. And then you would also have a file called vm1-flat.vmdk. And this file would have the same size as the hard disk. So if this hard disk is 20 GB inside of VM, it would be a 20 GB at maximum file on the data store. So whatever you have in binary data in blocks on the hard disk inside of the machine is actually binary data of the file flat vmdk. And the small vmdk file without the flat in the name, it is a descriptor. So it says that it's an HDD with 64 sectors, some number of blocks. So this is a descriptor of actual hardware statistics. And funnily enough, together these two files are shown as vm1.vmdk in the web browser. So if you look at data store here, you see that there is a single vmdk file, but if I try to download it, it gives me multiple file downloads. And one of them is flat, and one of them is this small descriptor, this database, which has geometry, sectors, heads, and basically tries to explain it as a hard disk to hypervisor to the best of its abilities. So if you do find a flat file on data store, it means that the vmdk file is lost or damaged, and the disk is kind of useless. And the same if you find a small vmdk without content which has a text inside, it means that you have lost your flat file. So normally, to avoid losing one of the two, the files are described as a single file. So if you move the disk between storages, it will use them both as a single file. But in reality, you would have two files. So these are the two of the most important files. Now, there is a specific action which is important to know about. It is called snapshot. So if I go to my virtual machines, right click and go to an action take snapshot, I can basically create a snapshot which will be able to roll back to basically restore the condition of my machine. So if I used to install some files, then take a snapshot and delete these files, after I roll back to the snapshot, I would get my files back. So let's take a snapshot and see what happens. Right click, snapshots, take snapshot. And I'll name it test1. So if I take a snapshot of this machine now, let me go to the snapshot manager. Okay, I will see that it appears here, and I used to have a snapshot before. So now this machine has two snapshots. What's actually happening here? If you go to the data store and browse it, you'll see that there are, besides one vmdk, there are two extra vmdk files, 0001 and 0002 vmdk files. So these are delta files created after I made the snapshot. I'll explain in the picture what it means. And if I go and I delete the snapshot, I will now lose these files and I'll be left with one vmdk again. So if I go to snapshot manager, I can click snapshots and delete them, or I can revert to them. So if I would click restore, I would go back. If I would click delete, I would get rid of the snapshot. So let me click delete all. This should get rid of the snapshots. It's in the task list. And now if I go to the storage and look at the same folder I just checked, now there's only one vmdk and the delta files are gone. So what's going on here? So because the vmdk, especially flat vmdk, is just a binary representation of your hard disk. So this is my HDD in the system where I have the C volume, and here let's say I have 1.txt file. As a real representation of the disk, I'll have flat vmdk file, which would have blocks on the file system in vSphere, and let's say there will be a couple of blocks filled with data, which represent the blocks filled with data from this text file. Right? So when I take a snapshot, there is a new vmdk file appearing beside it. And if this was vm1 flat vmdk, there will be vm1 0000001 flat vmdk. So it has specific naming. If I make more, it will be 2, 3, 4. And this is an empty file called delta file. So this is called now a base disk because it's original disk, and the new file created is delta file. And while the original disks had some other data useful by system and other applications, the new disk is completely empty. But because it is a disk, it can store data. So the VMX process, which was running, and reading and writing to this disk stops interacting with this VMDK, and instead it starts writing and reading into this delta file. Of course, you'll miss most of the information. So if I want to read this block number 5, for example, because it's not here, it will read from the previous file. So now technically a machine reads from both files, but it only writes in the new one. So if I would be going to the guest and deleting this file, so now these blocks would be discarded and overwritten. What would happen actually in the snapshot file, this one, or in the base disk, nothing would change, but the blocks would be erased in the new delta. And because it's actual data, like zeros, for example, the delta would start growing. And the more you work on the snapshot, the more blocks you start using. And now, in order to actually see what's happening in the guest operating system, you need to find the blocks from the new delta and from the old file which are not touched. And if I would delete the snapshot, what would happen? This file would overwrite the previous data. And now you would go back to a single file with the new state. And if I would want to restore the snapshot, so I would want to go back, I would simply erase this delta file, and then I would have access to the old data I had. So by doing the snapshot, you create a new disk to store the changes done after you make the snapshot. And if you delete the old snapshot, you override the snapshot with a new disk. And if you restore the snapshot, you delete the new disk and you go back to the old disk. That's pretty much the whole functionality. And this is how snapshot works. So there is no magic, no hidden storage. Basically, the more snapshots you have, the more disks you create, and each disk is a new version of your operating system and internal volumes. And you can create even trees, so you could go back to the old snapshot and you can make new snapshots. And the only limitation is that you can have 32 snapshot hierarchy in total, not deeper than that. However, one important fact is that you should not consider the snapshot a backup. So the snapshot is useful when you, let's say you want to make an operating system change, like update or reinstallation of components or some important tweak of feature setup. However, if you keep running the snapshot, your new disks will start growing and they will consume the store space. You may eventually even run out of disk space on your host. And it's not all the problem, because now your VMX process reads from 2 files, and if you make another snapshot, it will read from 3, 4, 5. You will highly increase the input-output per second versus fragmentation. So you would start reading from multiple places on your storage device. And theoretically, it would decrease performance of the machine. And besides that, if your parent disk would disappear, like if it would be deleted, you cannot rely only on the new delta file. You would have to use the old snapshot as well. So it cannot be used as a long-term backup, since by losing the original disk, you would lose everything. It's only a good thing to do for temporary changes, and then get rid of the snapshots once you don't need them, to save space and to preserve this activity. Besides the VMX file, right, we mentioned, besides VMDK, flat and descriptor files, there is also Nvram file. And this Nvram file is where the actual hypervisor stores the BIOS settings of the machine. And basically, this is where you have your BIOS of the virtual machines, and when it boots, it will use whatever is there to hold the Nvram data instead of battery, basically. It's a file of little significance, so you don't really worry about it too much, but you could have a custom BIOS setup, so that's why you would want to preserve this file. There is also ability to see VMSD, VMS descriptor, VM snapshot descriptor, and VMSN, VM snapshot text files. They will only appear when you create these delta files for snapshots. They will explain that let's say this 001 file is a child to the base disk. So they build the hierarchy of snapshots. So you can have a snapshot tree of different deltas if you make multiple snapshots. And finally, what you would want to know, there is a specific VMware.log file, which will only get created if the machine runs, and it can be useful to troubleshoot machine situation, like what happened, why did it crash, why did it reboot. It will log whatever the VMX process is logging. So this VMX process will log into VMware.log. But if the machine was shut down for some time, you wouldn't have this log, so you would have to rely on the host dlog on the ESXi itself if you want to check what happened with machine files or with machine functionality when the machine was shut down. There's one more interesting file you'll see in my environment. So if you go to the data store, you'll see there is a VMDK file which has CTK in front of it. So CTK VMDK. It is kind of VMDK like a disk, but it's not. So what it actually does, it stores disk changes over time from the last snapshot. So let's say you have a VMDK file which is flat, right? I forgot to mention that. And then you have this small VMDK which is descriptor of a disk. So on VMDK you have actual data like 011001, etc. in binary format. Actually, this binary format is stored in data blocks, the same as it would be in any system. So because we have Vmfs file system on data store in VMware, these would be Vmfs blocks. So what can CTK file, change tracking file, ctk.vmdk contain? When it is firstly created, it is empty, there is nothing. But when the machine starts changing data, so some data is overwritten here and here, CTK remembers that block number 2 is changed, block number 4 is changed, etc. So in the end, if you request what has been changing in the last specific point in time, this file will provide you with the history of changes. And typically it's used by backup applications. Let's say the backup has created a full backup of your disk, and then you run an incremental backup, which means that it's only a difference between backups. You could use this CTK information to find how much to read instead of reading the whole disk. This is why these files are quite important. VMware keeps them for backup applications to know what changes on the server. And it might be useful for even some VMware features, but I'm not 100% sure. What else? Yeah, if you open this file called VMX, let me find it. It was somewhere in my downloads. You can find an important information in the beginning: config version. So the virtual machines have different configuration and virtual hardware versions, which indicates on which version of the vSphere they have been created and which version of vSphere do they support, because there are some specific pieces of hardware and drivers which are only working on the newer version of ESXi and VMware. And to basically not have a problem with backwards compatibility, this is taken into account, so you cannot run a machine with a very new hardware version on a very old version of Hypervisor ESXi. Now, when the machine is running, and something I mentioned before when I was looking at my ESXi, you may have noticed that there is a specific parameters saying VMware Tools. So what is VMware Tools? VMware Tools is a set of drivers which you deploy inside of guest operating system. So it has to be specific version for specific operating system. For Windows it's one package, for Linux it's another. And while Windows OS is working, so you have your OS, it could be Linux OS, which runs its own kernel, it runs applications. It thinks that it runs on real hardware. So there is some hardware, and this machine thinks it's real. But what's actually happening is that this hardware is provided from the resources of the ESXi host using the hypervisor, and there is a bit of disconnect between the hypervisor and the machine. For example, if you configure here IP address 192.168.0.5, the machine doesn't have a function to tell, hey ESXi, I have this IP. So how would you be able to find out which address to use to connect to this machine? This is why you can install a specific application called VMware Tools, which comes as .iso file, and you can install it as easy as right click. So you click on the machine, right click, guest OS, install VMware Tools, and this option would attach an ISO file to the virtual CD-ROM of your machine. So it must have a virtual CD-ROM of sorts. And these tools know that the machine is virtual, and they will use a virtual bus to send information back to ESXi. So ESXi can know the IP, the state, and everything else. So this is how fault tolerance or availability can reboot the machine, or monitoring can reboot the machine if the machine goes down, because then the tools would go down, the communication would stop, and the ESXi could then react and restart the machine using VMware Tools. Now, if it is down, it's going to simply restart the machine as a process, as a VMX process. So this is a very important package, which is used for many integration reasons, such as guest backups, kind of finding how to connect, and just for your own good, so you could look at the machine and see what's the IP address, because right now I cannot, because I don't have the tools installed. For example, if I would look at the Vcenter, I would see that there is indeed tools running on my specific guest OS machine used as the ESXi, and that would let me see the IP address. Here I can find, because it says tools are running, and it tells me the version. So I mentioned that the data store has VMFS file system, but what is VMFS? Well, I'm not going to tell you what is a file system in a lot of details. I'm going to simply mention that basically it is the way data is allocated in partition. So normally if you format a disk, let's say you have a big HDD, you create a C volume for your operating system on Windows. I'm going with Windows because it's something that is quite common. And you select it to be NTFS. In the past, it used to be a FAT32, for example. And this is a specific driver which tells this final, let's say, SCSI controller to save data in a specific manner. But here we are talking about data blocks, about features like compression deduplication, about cluster size, about functionality like maximum file size. So basically, this file system defines a lot of specifics of how you save files. So for VMware, if you're using NFS connected from somewhere, it can be anything, because the NFS would be acting as its own file system. So if you have a share, you just connect it through NFS to your ESXi as an NFS data store. Then here you could have ext4, you could have NTFS or some other file systems, which would basically store your VMDK and other files. But if it is an Iscsi or SAS or public channel storage, so it's managed by ESXi system, here you would have to format it as a VMFS, which is now, I think, the latest version is 6.0. I need to check, but I think it is. And typically the block size, for example, of this system is 1 megabyte, and there are a lot of other things which are tailored for specific functionality of virtualization of hypervisor. But I would say, I think the most commonly used version is still 5. A lot of people use it still. So the main thing about new versions is the file size limitations. I think on 5 it was 62 terabytes, so I don't think you want to make a bigger virtual disk. It's easier to make multiple VMDK files. Why would you have such a big disk? Also, like let's say I think there used to be some servers with VMFs free, which I have seen sometimes in the past, but I don't think you can find those recently. Like, it's very hard to find it. So these VMDK files that you store on the VMFs file system, how do you connect them to the machine and which options do you have? Let me tell you. So again, returning to some basics, there is VMX process, which has configuration started from .vmx file, and then there is a vmdk and flat.vmdk disks, right? So these disks are theoretically written, unless you have snapshots, by the VMX process. How are they allocated on the storage? Let's take a look at the settings of the machine. At first, they could be standard disks, which have 3 different options. So if we go to the settings of the machine, you'll see which options I mean. Come on. Yeah, so if I expand the hard disk, I can select if it's dependent, independent persistent, or independent non-persistent. So the differences are the following. The dependent disk is the most common configuration which will be affected by snapshots. So let's say what's going to happen with the machine once it starts if it has 3 disks. So let's say we have 3 VMDKs. The last one will be dependent, and the first 2 will be independent, non-persistent, and independent persistent. So when you power on this machine, the data will start writing. When you take a snapshot, so now the machine is on the snapshot, there will be a new delta file created for dependent disk, which will start taking in new changes. But for original disks, the data will still go into them and they will be not affected by the snapshots. So independent disks are not affected by snapshots, only dependent disks are. So what is the difference between non-persistent and persistent? Let's say I shut down the machine and start it again. The persistent disk will be okay, and now the new changes will go further, so you'll keep changing the disk. For non-persistent disk, as soon as you reboot the machine, all the changes are gone. So you'll start writing data from scratch. So what is the use case of independent non-persistent? Let's say you create a machine with standard dependent disk and you install a browser, and well, before browser you installed Windows OS. So now this disk has Windows and browser. Then you kind of copy it or use it and you connected it as independent non-persistent to another machine that you want to use the VMX process. So once you start, a user can connect and start browsing. So you'll start doing some searches activity, watching videos, and after you stop, every history, every changes will be gone, and the machine can be used again. So this is useful for terminal servers, which do not need to keep any data, but they would provide functionality. This could be used, I don't know, like for example, in Internet Cafe, which doesn't store user data. And it also helps to actually prove that you don't store any data, because physically the data will be lost. Because what's happening, it does actually create a new file. You just don't see it normally. And this is also VMDK, which is delta. And whenever you power on the machine, instead of writing in the base disk, which has something, it starts writing into the delta. And of course, it uses the base disk to download the old data. But as soon as the machine is shut down, this delta is removed. So basically, it's like a spy machine, which you can do whatever with, and then you will have no data available on this machine. There could be situations where this would be useful. Now, besides that, you can see that the disk can be thick provisioned, lazy zeroed, and you could also make thin provisioned disks and thick provisioned eager zeroed. So if you add a new hard disk, here you would have an option to select the provisioning. I just need to wait for this to go through. I think it's here, yeah. So now I can select thin provisioned, thick provisioned, lazily zeroed, thick provisioned, eagerly zeroed. So you can only change it when you make a new disk. You cannot change it on the old disk. So what does it mean? So while dependent and independent explains how the disk is written and if it is snapshotable or not, thin and thick explains how the disk is allocated. So let's say you make a new hard disk which is thin, and you say thin 40 GB disk. It will be created as a very small, like 1 MB file with nothing. As you start working with the machine, so you have the VMX process writing, the disk will start growing. It will become bigger and bigger as you fill it with data until it reaches the maximum of 40 GB. And then it will not grow, then you will run out of space. And inside of the disk you can reformat it, you can change it, but the space gained will stay, so it doesn't shrink unless you use special tools. But it helps you to use only as much as you actually need. The downside is that every time it expands, it needs to use extra input-output operations for commands to expand the disk and actually allocate space. So the actual space allocation, when you increase total space usage, would slow down the operations. The thick disk, when you create it, let's say you make a thick 40 GB disk. It will immediately create the file, VMDK file, VMDK file of 40 GB. And then if it's eager or lazy zeroed, is only about zeroed actual data. So it could keep the data as is. There would be some 1001 which are not used, so they are there, but they're like on the storage level. In the system it will be all clean, and if you make it eager zeroed, it will take actual attempt to fully fill the disk with zeros. So now you don't have the old data anymore. So theoretically, the eager zeroed thick disk would be the most performant because everything is clean and it's prepared for your writes. In reality, lazy zeroed is good enough. And if your disk is like the storage system is fast enough, thin may be better, so you wouldn't over provision and consume the space that you don't need to use yet. Finally, the last type of disk, which I am not going to show you in my web interface, but I'll describe it, is called RDM. So what is RDM disk? RDM means raw disk mapping. And in this case, you wouldn't actually use a virtual disk. So let's say, again, we have ESXi, we have a VMX process, we have local storage, which is formatted with Vmfs. So here we have Vmfs, which actually has your normal VMDK file. And this disk for the machine, well, actually two VMDK files, flat and descriptor. This could be normal, thin, thick, dependent, independent. If you have a SAN storage, you can connect to it by Iscsi, and you can present a LAN by Iscsi. So here we have Iscsi target. And then this could be visible as a volume on ESXi. And you could pass through the volume into the guest. So instead of using the VMDK on the data store, it would use a volume from SAN through Iscsi, and this would be called RDM. Now there are two types of RDM, VRDM and PRDM, virtual RDM and physical RDM. And it is pretty simple. So what actually looks like here, you don't really put it directly through Iscsi. There is a file created, .vrdm or .prdm, which simulates this Iscsi connection. So you kind of connect a disk a file, but in reality, it's not a file, it's a link to the Esxi target. If you have virtual disk, you also create vmtk descriptor. So you will fool VMware thinking that there is also vmtk flat file. But flat is actually a lie, it's not here, it's a ghost. And the data you take from flat is downloaded from a Iscsi connection. So the virtual RDM fakes a virtual disk. You will not use space allocation on your LAN where you have the vmtk file, but you will appear as a virtual disk, so you can still snapshot it. Physical RTM doesn't try to pretend to be a virtual disk. It's clearly that it is a specific LAN from another storage, and you cannot snapshot physical RTM disk. There are different reasons why you would want to use RDM, but you could also simply create vmtk file on a Iscsi target and mount a Iscsi data store and use it as a local disk, and it would give you a lot more functionality like migration, storage remotion. So there are only some niche applications where you would want to create RDM files. Okay, now there are a few steps I want to describe about networking and which things you would like to take into account, but I want to put it in the second part of the training because it's already a bit too much. So right now we have focused on the deployment on virtual machines, on types of storage and on files, and the second video will cover networking and extra functionality. It will also include virtual SAN and virtual volumes, which are new features kind of in the latest vSphere 6 and later. But I'll just quickly explain what it is about. So up to this point, you should know everything to start learning further into each of the concept. And if you have any question about specifics, I will be more than happy to answer them. You can look forward to the second part of the lecture about networking and advanced features within a few days. I just need time to prepare. And thank you so much for watching. I will see you in the next video. Bye bye.